Hi, now we're going to get some practice solving compound inequalities, and we're going to write our answers in interval notation. So, in this first example, -7 less than or equal to 2x minus 3 and 3x plus 1 less than 7. Okay, so with any compound inequality like this separated by an and or an or, we're going to solve both of the equations that we see. So, in this first one, -7 less than or equal to 2x minus 3, I'm going to add 3 to both sides. So I'll have -7 plus 3 less than or equal to 2x minus 3 plus 3, which will leave -4 less than or equal to 2x. Divide both sides by 2. So -2 is less than or equal to x. With an and statement, it might be advantageous to leave x on the right. You can move it over on the left if you want to. I'm going to leave it alone for the moment. Okay, so now with the 3x plus 1 less than 7, I have to subtract 1 from both sides. So I'm going to have 3x plus 1 minus 1 less than 7 minus 1. So then I have 3x less than 6. Divide both sides by 3. X is less than 2. Okay, now remember there's an and statement going on through all of this, right? So I have 2 less than or equal to x and x less than 2. So I really, with a -2 less than or equal to x and x less than 2, I really have -2 less than or equal to x less than 2, right? So if I'm thinking about that as an and statement, you can also think of the number line, or also think about that inequality as eating the bigger number, right? So x is really bigger than -2, and it's really smaller than 2, right? So the intersection of those things is going to put x between the two. All right, so the solution set is -2 to 2, and I'm using a closed bracket at -2 and an open bracket at 2, right? Because I have -2 less than or equal to x and x strictly less than 2. All right, in this next example, I have x plus 5 less than -3 or x plus 5 greater than or equal to 4. So again, it's an or statement. Whether I have an or an and statement, I want to solve both of those equations. So in the first one, I have to subtract 5 from both sides. So I have x plus 5 minus 5 less than -3 minus 5. So x is less than -8. Okay. With this second equation, I'm going to have x plus 5 minus 5 greater than or equal to 4 minus 5. So x is greater than or equal to -1. Okay, so this is an or statement. So I have x less than -8 or greater than or equal to 1. Okay, now it's wise. You don't have to. It doesn't hurt to think about this on the number line, right? 1, 2, 3, 4, 5, 6, 7, 8, -8, and x is going to be less than that or greater than or equal to -1, so out this direction, right? So sometimes seeing it on the number line is helpful. Don't be afraid to do that out on the side of the page somewhere, right, if you need to. So the solution set is -infinity to -8 with an open bracket in union with -1 to positive infinity, and I'm using a closed bracket at -1 since we're including it. Okay. Great. And so with this or statement, again, we have to include everything in both intervals. If this was an and statement, we wouldn't have a solution, right? Because they don't intersect anywhere. But with an or statement, we have to include both of the intervals. All right, so let's do this next example of 2x minus 6 greater than -14 or 3x plus 5 less than or equal to 23. So again, I'm going to solve both of these equations. In the first one, I have to add 6 to both sides. So I have 2x minus 6 plus 6 greater than -14 plus 6. So 2x is greater than -8, right? -14 plus 6 is -8. Divide both sides by 2. X is greater than -4. Okay. All right, and with the other equation, I have to subtract 5 from both sides. So I have 3x plus 5 minus 5 less than or equal to 23 minus 5. So now I have 3x less than or equal to 23 minus 5 is 18. Divide both sides by 3. X is less than or equal to 6. Okay, again, this is an OR statement. So I have x greater than -4 or x less than or equal to 6. All right, so let's take a look at, I'm running out of room here. Let's take a look at this. 1, 2, 3, 4. Here we go. Okay, so greater than -4 or less than or equal to 6. 1, 2, 3, 4, 5, 6. Okay. Now this is one of those cases where when I put both of those intervals on the number line, I end up shading the whole number line, right? And I don't want just the intersection here, I want everything. So the solution set here is going to be -infinity to infinity. Okay, in this last example, I have 2x minus 7 less than or equal to 5, or 5 minus 2x greater than 3. All right, so solve them both. 2x minus 7 plus 7, got to add 7 to both sides here, is less than or equal to 5 plus 7. So then we have 2x less than or equal to 12. Divide both sides by 2. X is less than or equal to 6. Okay. Now for the other equation, I have to subtract 5 from both sides. So I have 5 minus 2x greater than 3 minus 5. So -2x is greater than -2. Now I have to divide by a negative, right? Okay, now in all the other examples we just did, we didn't divide or multiply by a negative. In this case, when we're dividing or multiplying by a negative, we have to reverse the sign of the inequality. So we're going to have x less than 1. And this is an OR statement, right? So 1, 2, 3, 4, 5, 6. X less than or equal to 6, right? Or x less than 1. Okay, we have to use all of it, so including their intersection. So if I shade everything, if I write everything that I see in interval notation there, I'm going to have -infinity up to 6, right? So the x less than or equal to 6 wins out there, right? So like I said, you don't have to write things on a number line, but I think sometimes it could be really helpful just off on the side somewhere. What do we have with this?